All right, here we go. We are looking at bombardment. As you can see, I've reduced the number of languages that I'm going to implement this time because for a couple of reasons. One, I think that what I have done in the languages such as COBOL and HASKEL and things like that, even LISP, I think it's given enough flavor. Like I think that if you're interested in what that language looks like and how you implement some things in that language, I think that you can just go ahead and look at those videos or go look at my website and see the implementation yourself. So not really enjoying as much as I thought I would programming in, say, like COBOL again. It's been literal decades since I actually had to work in that, and I don't really want to do it for some of the fun stuff that I want to do. And quite frankly, I want to build more and more advanced kind of things. Not that some of those languages can't do it. It's just that it's can be kind of a slog. It could be less entertaining. In fact, it's very possible that these videos going forward, if I reduce them down to, I don't know, 3 or 4 languages that are different enough and aligned enough to allow me to do some of the more advanced stuff that I want to do, that might be a single video with breaks so that you can jump to the implementation that you want to see. I feel like the series is sort of getting out of hand, and I think I've accomplished what I want to accomplish. So let's just do these 7 this time, and then I think next time we'll probably drop maybe C++, just because it's really, I can do much of what I can do in C++ and C#. They're very similar languages. C and C++ are definitely much more powerful, I would say, as far as like being able to do some closer to the metal work. You can get in a lot more trouble with them, with pointers and things like that. And as you see, I dropped Visual Basic.net because that's honestly it's just a different skinning of C#. And C#, I think that the videos would be a little bit more maybe interesting. I'm also thinking that this may evolve into something a little bit different as well. Maybe we will, as we end up with 3 or 4 core languages to implement these console apps in, maybe we then, I don't know, jump over to like Unity or whatever, and implement a graphical version of these more complex items that I want to get into. So that being said, let's get through this one. It's already been rambling for 4 minutes. We're going to do Ada, Basic, C++, C#, Lua, Pascal, and Python. I'm probably also going to drop Python just because that is a language that many people use on a daily basis. I for sure use it. So it may not be my poor implementation in Python might not be that interesting. It might just irritate people. So let's talk about our variables. Our global variables are your grid, enemy grid, and outposts. These are 3 arrays. 2 of them are array of integers, 25 slots. They're not multi-dimensional arrays. You don't need to do that for this. It makes it somewhat easier to do some things. In fact, although we'll get to it. Display rules. These are the rules. You're on a battlefield with 4 platoons and you have 25 outposts available where they may be placed. You can only place 1 platoon at any one outpost. The computer does the same with its 4 platoons. The object of this game is to fire missiles at the outposts of the computer. It will do the same to you. The first one to destroy all 4 of the enemy's platoons first is the winner. Good luck, and tell us where you want the body sent. Check winner is simply if the player has no outposts, return 2, then the computer 1. If the computer has no outposts, return 1, player 1. I think that if these languages, and I think they do, allow me to do a little constant or just have a variable that is it, this might just say player, and this might say enemy, and this would be enemy, and this would be player, and that way it's a little bit more visually readable. Display your grid, goes through and display this line, your grid, this line. I believe I'm going to clear the screen before we display stuff so that, we have, I think we're going to take a little bit more liberties with these. But anyway, it puts an X if you have a destroyed outpost, otherwise an O for an outpost, blank for nothing. Enemy grid doesn't show you the outposts, it only shows you the destroyed ones. So really this is just else here. Clear grids just loops through and puts zeros into all the slots. Set outposts, you have 4 outposts. It will loop from 0 to 4. It will ask you for the X and Y coordinate of the outpost. It has to be between 1 and 5. And then it uses a simple little formula to figure out where that is within the 25 items and sets that to 1 right here. Computer set outpost, it just is going to generate a random number between 0 and 24. Set that outpost. Computer turn. Now, this is where I was thinking about it. I'm doing this for computer set outposts, but instead I'm doing this for computer's turn. I don't think that's needed. I think that I can turn this into the same thing as this. You can pick a slot. It's the same thing. This location, this little formula ends up making this a 0 to 25. If he'll go spoom, he'll either missed you, dirty rat. I pick location XY. That might be the only reason why I want to do that, so you know where he fired. Okay, I think I'll leave it. I got you, won't be long. Outpost at XY was hit. That's if he hits you. 3, 2, 1, you're dead. You fire a missile, it asks you where you want to fire a missile. Ask for X, ask for Y. Must be a number between 1 and 5. Makes that little formula, spoom. If it's -1, you've already attacked there. Otherwise, you missed. Otherwise, you got one of my outposts and decreases his outpost by 1. 1 down, 2 down, 3 down. You got them all. Game loop variables, there'll be a turn. We'll display bombardment in the language. Turn to 0. This is ASCII rules, running. Clear the grids, computer set outpost. Let the war begin. Display, turn, and this is where I think I'm going to, do something like, press. Something like that, maybe. And then we'll say, whatever, This is possible. We'll see. I don't know. We'll see what it looks like. We're gonna mod the turn by 2. If that ends up being 0, then it's your turn. Otherwise, it's computer's turn. We'll display your grid, display the enemy grid, fire the missile, or computer's turn. We'll check the winner. If the winner is 1, so it's the player, then we'll display your grid, display the enemy grid, and display you win. Set game over to true. Else if the winner is 2, display your grid, 2 bad. So I think what I really want to do here is I'm thinking about this. Maybe we want to say if winner is 0, then increment turn by 1. Else we'll say, I think we'll display your grid, display the enemy grid, display you win, else display 2 bad, better luck next time. Set game over to true. Does that make more sense? Collapse that up a little bit. Yep. I asked to play again. Thanks for playing. I think I also want to do, let's do display. Yeah, let's do that. Yep, so it should be fairly quick to implement. We'll do them in all these languages. Let's get going.